Alright, so today we're going to be doing homework number 1, problem number 37. And that one reads as, an opera singer in a convertible sings a note at 600 hertz while cruising down the highway at 90 kilometers per hour. What is the frequency heard by, and these are two frequencies, A, a person standing beside the road in front of the car, and B, a person on the ground behind the car. Now, right off the bat, first thing we do with any equation is list the knowns. So the knowns that we do know are the frequency of the source, which is given 600 hertz. There you go. And next thing we know is the velocity or speed of the source, which is the opera singer cruising down the highway at 90 kilometers per hour. Now, since we don't like to work with kilometers that much, we can convert it to meters per second, which then equivalates to 25 meters per second. And another known that is not given here, but that it is a given in these kind of problems, is the speed of sound, which is 343 meters per second. Now, what you're trying to find is the frequency heard by both A and B. Now with this, it is actually two different frequencies because, as we can show here, the opera singer is driving one towards person A, and the person B is back here. Person B. Now, the opera singer is emitting these sound waves in all directions, although one is being traveled to A, and the other is, I guess, away from B. So this one is going away. Now, these are two different frequencies because it is heard differently by person A and B. Now, we should expect A to be higher than B, since the source of the frequency is moving closer rather than away as in B. So if we look from A, we start with part A, we use the equation for this specific problem, which is the Doppler effect, and we use it for an approaching source instead of a departing source. Now the approaching source equation is the frequency of the source over 1 minus speed of the source over the speed of the sound, which is as given. Now, all we do for here really is plug in as we are given the three that we need to know, the frequency of the source and both speeds. So we plug in. This is 25 meters per second over 343 meters per second. We do some simple math, which if we can pull up on here, will show as 25 divided by 343, 1 minus 0.0729, which then we do 600 hertz divided by 1 minus that, which then gives us 647.170 hertz, which we can then round to 650 hertz to three significant figures. So this is for the approaching sound as the opera singer approaches part A. Then we move on to part B, which is person behind the car. So this is the departing sound, the frequency, and that one is given as, very similarly, frequency of the sound is on top. However, now you add the speed, and the reason you add here instead of subtracting is the speed is going farther away, so the distance traveled is increasing from part B to the opera singer, whereas A It is decreasing because the distance between these two is decreasing over time. Hence, opera singer is getting closer to B and going farther away from, getting closer to A and going farther away from B. That is why the difference in the plus and minus. Now, similarly, we plug in the numbers, same numbers, just in addition. 43. We are then left with on top as well 600. Now we add this, and if given, we will do the same situation. And this